Hi friends, today I am giving a lecture on Strassen'S matrix multiplication in divide and conquer approach. So Strassen'S matrix multiplication is one of the Hi friends, today I am giving a lecture on Strassen'S matrix multiplication in divide and conquer approach. So Strassen'S matrix multiplication is one of the efficient matrix multiplication compared to the conventional matrix multiplication. So it can be developed by Walker Strassen. Okay. So before going to Strassen'S matrix multiplication, first how to multiply two matrices. Okay. So let us take two matrices A and B with the size n by n. Now we have to multiply these two matrices. Then we can get the resultant matrix, that is C, with the size n by n. Okay. How to multiply these two matrices? Okay. So now we can take the ith row of matrix A is multiplied with jth column of matrix B. So in this way we have to perform the matrix multiplication. So for example, so this is matrix A. It contains four elements A11, A12, A21, A22. So here the matrix size is 2 by 2. Here n is equal to 2, that is 2 by 2. Now we can take another matrix with the size 2 by 2, that is n is equal to 2. So the elements in matrix B are B11, B12, B21, B22. Okay. So now we have to multiply these two matrices. So that is, then we can get the resultant matrix C. Okay. So C of ij is equal to sigma 1 less than or equal to k less than or equal to A of I comma k into B of k comma j. So by using this formula, we have to find out the resultant matrix C that can be obtained by multiplying these two elements with these two elements. So that is A11 into B11 plus A12 into B21. Next, A11 into B12, A12 into B22. Okay. So that is C1 value is this one and C12 value is this one. How can you get C21? So that is A21 is multiplied with the B11 plus A22 is multiplied with B21. Next, A21 is multiplied with the B12, A22 is multiplied with the B22. Okay, so in this way we have to find out the multiplication of two matrices A and B with size n is equal to 2. Then we can get the resultant matrix C with the size n by n, where n is equal to 2. The elements in the resultant matrix C is calculated by using this formula. Then we are getting these values. So C11, this value, C12, this value, C21, this value, C22, this value. Okay. So it is multiplied with this one. Again it is multiplied with this one. So this is multiplied with this one and this is multiplied with this one. Okay, now C11, C12, C21, C22. Now observing this multiplication process, okay, how many number of products are there? How many number of products are there? So this is one product, this is another product, this is one product, this is another product, this is one product, this is another product, this is one product, and this is another product. How many number of multiplications are there? 8 multiplications are there and 4 additions are there. Okay, to perform this multiplication operation with the size 2 by 2 between two matrices, how many number of multiplications are required? 8 multiplications are required and 4 additions are required. So next, the computing time required to perform matrix multiplication with 2 by 2 matrix. So the recurrence relation P of n is equal to, if n less than or equal to 2, so the computing time is 1 unit time or constant time. If n greater than 2, so the time complexity is 8t n by 2 plus n square. Here 8 represents the number of multiplications. How many number of multiplications are there? 2, 2, 2, 2. That is 8 multiplications are there. Plus n square. N square is nothing but how much time that can take to perform the addition. Okay. So that is n square. So this is the recurrence relation that can be used to perform matrix multiplication between two matrices with size n by n. Okay. So by calculating this recurrence relation by using substitution method or master method, so the time complexity for matrix multiplication is P of n is equal to big O of n cube. Okay. So here we have to take only 2 by 2 matrix. That is a small problem. So that 2 by 2 matrix can be treated as a small problem. Okay. The Strassen'S matrix multiplication is developed by Walker-Strassen's. So this Strassen'S matrix multiplication was developed by Walker-Strassen. Okay. It is the Strassen'S matrix multiplication is faster than conventional matrix multiplication. Okay. Next one, here the divide and conquer strategy suggests that another way to compute the product of two n by n matrices. Here we have to use the divide and conquer technique if the size of the matrix is greater than 2. Okay. So here by using this technique, how to perform the matrix multiplication by using Strassen'S matrix multiplication, then we have to reduce some number of multiplication operations that are replaced by using addition operation. So then cost of the matrix multiplication is reduced. Generally, so multiplication requires more cost compared to the addition. So addition requires less cost, so compared to the multiplication. So here in the Strassen'S matrix multiplication, there are 8 multiplications are there. These 8 multiplications are reduced into 7 multiplications. So because of that reason, the cost is also reduced and the time complexity is same. So time complexity is slightly approximately same. Okay, here in the conventional matrix multiplication, the time complexity is big O of n cube, but in the case of Strassen'S matrix multiplication, the time complexity is big O of n power 2.81. That is slight changes. Okay, so this slight changes can be occurred because of one matrix multiplication is reduced by using addition operation, because multiplication requires more cost compared to the addition operation. Previously, we have seen if the matrix size is n by n, where n is equal to 2, then how to perform multiplication between the matrices A and B. So that require C11, C12, C21, C22. So that has 8 multiplications and 4 additions. Now we have to improve the size of the matrix, that is n by n, where n is equal to 4. So if n is equal to 4, so that is how to perform matrix multiplication that we have shown. So here imagine that A and B are two matrices are partitioned into 4 square submatrices. So here we have to apply the divide and conquer technique. Okay, now each and every matrix can be partitioned into n by 2 and n by 2 matrices. So that the given matrix A can be partitioned into 4 n by 2 and n by 2 matrices. Again, matrix B is also partitioned into 4 n by 2 and n by 2 matrices. Then the product AB can be computed by using the formulas C11, C12, C21, C22 for the product of 2 into 2 matrices. After partitioning the given matrices A and B, so n by 2 and n by 2 matrices, then we have to calculate C12, C2, C11, C12, C21 and C22. Okay, so this is the given matrix A, this is 4 by 4 matrix, and this is the given matrix B, that is also 4 by 4 matrix. So each matrix is divided into n by 2 and n by 2 parts. So the given matrix A can be partitioned into 2 by 2. So this is 2 by 2 matrix, and this is also 2 by 2 matrix, this is also 2 by 2 matrix, and this is also 2 by 2 matrix. So after applying the divide and conquer technique, so the given matrix A is partitioned into 4 n by 2 and n by 2 matrices. Again, the matrix B is also partitioned into 4 n by 2 and n by 2 matrices. Okay, the first part is A11, the second part is A12, the third part is A21, fourth part is A22. In the same way, the first part is B11, the second part is B12, the third part is B21, and fourth part is B22. Again, the matrix can be formed as 2 by 2 matrices. So then we have to found C11, C12, C21, C22. We can attempt to reformulate the equations for C of ij so as to have fewer multiplications and possibly more additions. So multiplication cost is more than addition cost. Next, Strassen'S has discovered one way to perform the matrix multiplication that have 18 additions or subtractions and 7 multiplication. Here, Strassen'S developed a way to perform the matrix multiplication of A and B matrices. So by using only 7 multiplications and 18 additions or subtractions. So he has to develop some equations to perform the matrix multiplication. Okay. So here 7 multiplications and 18 additions or subtraction. So in this one, first we have to calculate 7 equations, that is P, Q, R, S, T, U, V. So in this one, in these equations, so there are 7 multiplications and 10 additions or subtractions are there. By using these 7 equations, we have to formulate C11, C12, C21 and C22. So total, by combining these 7 equations P, Q, R, S, T, U, V and C11, C12, C21, C22, total, so 7 multiplications and 18 additions are subtractions. But in the case of 7 equations P, Q, R, S, T, U, V, only 7 multiplications and 10 additions or subtractions are there. So after applying the divide and conquer technique of 4 by 4 matrix, then we have to get this one. So the matrix A contains only A11, A12, A21, A22. Matrix B contains B11, B12, B21, B22. So by using these two matrices, first we have to find out 7 equations. So after that, by using these 7 equations, we have to find C11, C12, C21, C22. So first one, the equation P is equal to, first we have to combine diagonal elements. So A11 plus A22 is multiplied with adding diagonal elements in matrix B. So B11 plus B22. So adding diagonal elements in matrix A, that is A11 plus A22, adding diagonal elements in matrix B, B11 plus B22. So both are multiplied. Second one, Q is equal to, next we have to add these two, A21 plus A22, A21 plus A22 is multiplied with B11, is multiplied with B11. Next, R is equal to, subtracting the second column, B12 minus B22 is multiplied with A11. Next, S is equal to, S is equal to, we have to combine the first row. So that is A11 plus A12 is multiplied with B22. This one. Next, T is equal to A22 so A22, then B21 minus B11, B21 minus B11. Next, U is equal to, we have to subtract these columns. So that is A21 minus A11 into first row, B11 plus B12. B is equal to, now subtracting this column, A12 minus A22 into B21 plus B22. Okay. So these are the 7 equations. By using these 7 equations, we have to found C11, C12, C21, C22. So in these 7 equations, okay, how many number of multiplications are there? 1, 2, 3, 4, 5, 6, 7. So 7 multiplications are there in PQRSTUV equations. How many number of additions or subtractions are there? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 additions or subtractions are there. 7 multiplications are there. Okay. Next, we have to find out C11. C11 is equal to P plus S minus T plus B. So P plus S plus minus T plus B. C12 is equal to R plus T. C21 is equal to Q plus S. C22 is equal to P plus R minus U minus Q. P plus R minus Q plus U. So in this one, there are 7 multiplications are there and 10 additions or subtractions. By using these 7 equations, we have to find that C11, C12, C22. In this one, how many number of additions are there? So 1 additions or subtractions 1, 2, 3, 4, 5, 6, 7, 8. So here 10 additions or subtractions are there. Here 8 additions or subtractions are there. Total there are 18 additions or subtractions. In this one there are no multiplications are there. In this one there are only 7 multiplications are there. So by using these Strassen'S matrix multiplication, we have to require 7 multiplications and 18 additions or subtractions. So in the conventional matrix multiplication, we have to require 8 multiplications. Okay, 8 multiplications and 4 additions. Okay, so by using this Strassen'S multiplication, so in this one the matrix multiplication is more cost compared to the matrix additions. So now we have to reduce fewer multiplications that can be replaced by using some number of additions or subtractions. In the conventional matrix multiplication, we have to require 8 multiplications. So by using this Strassen'S matrix multiplication, in this one, so there are 7 multiplications out there. Now we have to reduce 1 multiplication, so that can be replaced by fewer number of additions or subtractions. So this is the description about the Strassen'S matrix multiplication.